Hello, this is Elizabeth from the Academic Support Center at Raritan Valley Community College, back going through these problems from the Pre-Calc 2 review packet. So problem 11 was to find the exact value of tangent of the inverse sine of 1/2. This inverse sine, what it's really asking is, the question is sine of what angle is equal to 1/3? Okay. So we're looking for that angle. We're looking for that theta. Because sine is cyclical, we have to restrict the domain on this. So our answers have to be for this one. It has to be from negative pi over 2 to pi over 2 when we're doing the inverse sine. Okay. Graphically, I'm very visual. So like I like to think about the sine curve that looks like this. Well, I didn't do a very good job, but we need a place where there's no repeat in the y values. So we're going from negative pi over 2 to pi over 2. And if we're talking unit circle, we need some place where the y values don't repeat, and that's here between pi over 2 and 2. So however you like to remember that, is that, but we're looking for something where sine is equal to pi 1 over 3. It's between negative pi over 2 and pi over 2, so it has to be actually between 0 and pi over 2. It has to be in the first quadrant, and I like to draw a triangle. So I did that really bad. We're going to draw a right triangle. Again, that's not a very good right triangle. Pretend that's a right angle, and this is our theta. Now sine of that angle is 1 over 3. To find tangent, we need the adjacent side. So we can find that adjacent side using the Pythagorean theorem. This side is x, so 1 squared is 1 plus x squared is equal to 3 squared, which is 9. Okay, so x squared is going to equal 8, or x is equal to the square root of 8. 8 is equal to, this is equal to the square root of 4 times 2. The square root of 4 is 2, so we can write this as 2 square roots of 2. So this x here is equal to 2 square roots of 2. So tan of theta is our opposite one over our adjacent, which is 2 square roots of 2. Okay, we have to normalize this, so we're going to multiply by the square root of 2 over the square root of 2. This becomes square root of 2 divided by 4. So that's our tan of theta. Okay. The next problem tells us that sine of x is equal to 4/7, and cosine of x is equal to negative square root of 33 over 7. It's asking what cotan is. So cotan is the inverse of tan, but it's cotan x is cosine x divided by sine x. Okay, it's an identity that I think probably you should commit to memory. So now we just have to plug this in. We know what cosine x is, and we know what sine x is, so we can plug in. So cosine x is negative square root of 33 over 7, and this is divided by our sine of x, which is 4/7. Now we have a compound fraction here, so let's rewrite this. When we divide by a fraction, we can multiply by its reciprocal. We're going to multiply by the reciprocal of 4/7, which is 7/4. Our 7's cancel out, and we get that the cotan of x is equal to negative square root 33 divided by 4. Okay. Numbers 13 and 14 involve proving trigonometric identities. Now, when I prove trigonometric identities, there are 2 things that are really key, and you can solve a whole bunch of these problems with just these 2 things. One is we want to rewrite in terms of sine and cosine. Okay, and then 2 is look for Pythagorean identities. So those are sine squared x plus cosine squared x equals 1. That's the base form of our Pythagorean identity, but we can also do, we can also say, we can subtract cosine from either side and we get 1 minus cosine squared x equals sine squared x. We could subtract sine from each side and we get 1 minus sine squared x equals cosine squared x. So between these two things and algebraic manipulation, we can usually solve most of these. I'd really encourage you to pause this video and try and do this problem, keeping those two things in mind before you listen to it. Once I show you how to do it, it looks really easy. Okay, so secant x is 1 over cosine x. So I'm going to rewrite this as 1 over cosine of x minus cosine of x divided by tan x. So we're going to write that tan x in terms of sines and cosines. Well, tan is sine over cosine. So we're going to rewrite this as sine of x divided by cosine of x. Okay? I have cosines in my denominator in both parts of my fraction, so I'm going to multiply the top and the bottom of this whole fraction by cosine of x over cosine of x. Okay, so this whole thing times cosine of x. So 1 over cosine of x times cosine of x, that's just 1. Cosine of x times cosine of x, this is cosine squared of x. Sine of x divided by cosine of x times cosine of x, our cosines of x cancel out and we get sine of x. Okay, now, so we replaced our sines and cosines, we did a little bit of algebra. Now we have something that's one of our Pythagorean identities. This is equal to sine squared of x over sine x. Sine squared of x divided by sine x, this is just equal to sine of x, which is what we were originally trying to prove. Okay, so again, rewrite in terms of sine and cosine, do some algebraic manipulation, and we look for our Pythagorean identities. If we look at this one, same thing. We're going to follow the same steps here. We're going to replace our sines and our cosines, or our trig functions with sine and cosine, and we're going to do some manipulation. Whenever I have something on the left, on my right hand side that's not just a sine or a cosine, I kind of like to think about what that is. So this cosecant squared is 1 over sine x squared. So ultimately we want to get this to look like 1 over sine x, and then we'll convert that to cosecant. Okay, so again, same thing. We want to replace anything that's not a sine or a cosine as a sine or a cosine. So this sine x stays here. But this cosecant is 1 over sine x. Secant is 1 over cosine. So this is 1 over cosine squared x. Okay? Now again, I want to, instead of dividing by a fraction, I want to multiply by its reciprocal. So I can rewrite this as sine x plus 1 over sine x times cosine squared x over 1. So this becomes sine x plus cosine squared x over sine x. But in order to add things, I have to have a common denominator. So I'm going to multiply this sine x times sine x over sine x. So we have a common denominator. So all of this becomes sine squared x over sine x plus cosine squared x over sine x. Now I have the same denominator, so I can add my numerators. Well, sine squared x plus cosine squared x, that's my Pythagorean identity. That's just 1. And this is over sine x. And then 1 over sine x equals cosecant of x, which is what we were trying to prove. So if we were really to be rigorous, we'd have equals cosecant x all along here, equals cosecant x. This is equal to cosecant x. So this checks. Okay. I don't think I'm going to have time for the last problem, so I'm going to leave it here with 14. But I will be going through the other problems. So if you have questions on these, or if you have questions on if you need more help with these, or if you have questions on other problems, there will be other videos, but we're also available for online tutoring at the Academic Support Center.